Hello, hello, hello. Welcome to Yebo Tutor Livestream. It's been quite some time, but welcome. Let's tune in, let's prepare for this control test. Hello, Danny. Hello, Danny. How are you doing? Just typed something on the live chat. I'm seeing Danny said hello. Hello, Danny. How are you doing? Can we have other people to type as well? It's gonna be an amazing 30 to 40-minute session. We're just gonna do the final preparatory for the control test for maths. Oh, I'm so good, Danny. It's great. The weather is allowing us to practice maths to prepare for the control test. Let's go, let's go, let's go, let's go. If it's your first time to tune in, please don't forget to subscribe. If you're a returning subscriber, thank you so much for coming, and we hope that we'll be able to assist each other. Don't be afraid to ask any question. Please do ask questions. If you have questions, ask us in the comment section, or you can ask us on the WhatsApp group. Let's go, guys, so that others are already ready. Let's go. So today we will be doing the easiest, I suppose, which is to prepare for the final control test for term 1. So what we will be doing today, it's not that hard. It just needs you to be able to listen attentively, and we will be able to cruise together. So I prepared the question last week, then I posted it in our WhatsApp group. So that's why I always advise that if you're not in the WhatsApp group, you will not get the material. So please do join the WhatsApp group. From the description of this video, you can join the WhatsApp group. So you can see this is Yebo Tutor from Nelson Mandela University. I prepared the test for you guys 2 days ago. This is question 1, question 2, question 3, 4. Last week I heard from, I think it was Langelihle. He said or she said that we'll be doing graphs and functions in the control test for this year. So there's no Euclidean geometry, guys. So we'll do number patterns as well as functions. Let's get down to the business of the day. Question number 1. Question number 1. Let's see. Let's use a red pen. Yes. Given the quadratic sequence, this is now getting tiring. Guys, we now know how to solve a quadratic sequence because we know that what is a quadratic sequence, and we can define it and say a quadratic sequence is a sequence which has a second constant difference. So the idea behind everything is for us to understand everything before we even answer the question. So we must be able to um, conceptualize first. Okay, let's go. What do they want? They are giving us this quadratic sequence. Determine expression for the Tn for the quadratic sequence. This is easy. 1.1. Why? We know that Tn is equal to an squared plus bn plus c. This is quite a big. Let's reduce it. Here we go. How do you find A? We know that 2A is equal to D. So again, the same strategy works. So before you use these, you must be able to find the second constant difference. So 34 is to 42 is to 48 is to 52. So let's go 42 minus 34. That should give us, let me use my calculator. That should give us 8. So always, guys, when we are coming to our class, we always bring our calculators so that we can assist each other, right? So please bring your calculator. Here is my calculator. Also bring your calculator in the process. So 42 minus 34 is equal to 8. 48 minus 42, that's 6. Then 52 minus 48, that's 4. Then we had 54 here, so 54 minus, then we have 2 in this instant. This is the first difference, but we know that the quadratic has a second constant difference. So 6 minus 2, it's going to be equal to, 6 minus 8 is equal to -2, 4 minus -2, and also -2. So our D is equal to -2. Let's go, let's go, let's go. Now we know that Tn is equal to an squared plus bn plus c. How do you find a? 2a is equal to d. So 2a will be equal to, what is our d? Our d is -2. We divide both sides by 2, divide both sides by negative, then we have our a to be equal to -1. Now, how do we find the value of b? So 3a plus b is equal to t2 minus t1. What is a? It's -1 plus b equal to, what is t2 minus t1? Let's go, let's go. Here is t2 minus t1. So we're gonna have our 8. Then b is equal to 8 plus 3. Then our b is equivalent to 11. Just like that, we have our value of b. Everything is nice. We are cruising nice. I'm also checking on the WhatsApp group. If you have any question, do ask us so that we can be cruising together nicely. And how do you find the value of c? As always, a plus b plus c is equal to t1. Our a is -1, our b is 11, and now we want to calculate c given t1. T1 is the first term of the sequence. In this instance, it's equal to 34. So it's equal to 34. Then c will be equal to 34. Um, it's going to be 34. Then 11 minus 1, that's 10. So it's going to be 34 minus 10. Then our c is going to be equal to 24. Then now we can conclude. If you just leave the letters, your answers is automatically wrong. So please make it a point that when you are done calculating a, b, and c, now write the general term that tn is equal to -n squared plus, what is our value of b? It's 11, 11n plus 24. Then you get your all 4 marks for being able to write it in the proper way. Just like that, you have your marks. Are we happy? Are we happy? Are we happy? Oh, great. I am seeing that we are happy on this other side. Let's proceed to the next question. Now, ladies gets 20th term to be -155 without doing any calculations. Explain why this answer has to be incorrect. This answer definitely is incorrect, guys, because we can see that the sequence is made of even numbers. That one is just definitely straight like that. So we can say that the 20th term to be -55, 155, that's wrong. Why? Because -155 is a odd number. So you get 1 mark for that. Okay, then you can also explain and say, whereas the sequence has, or let's say is made of even numbers. So definitely it's incorrect because -155 is an odd number. And we can even see here, these are multiples of 2. 8 is a multiple of 2, 6, 4, 2, 34, 44, 48, 52, 54. So we can definitely see that we can never have -155 because 155 is an odd number. Then on 1.3, 4 marks, 4 minutes, 1 mark, 1 minute, so that we'll be able to finish our exam or our test which we'll be writing. So please, let's make it a point that we do in that sense. Great. Let's proceed. Let's proceed. Now, the next question says the general term of the first row of difference is Tn equal to -2n plus 20 for a certain value of p. The pth term of the quadratic sequence is equal to the pth term in the first row of differences. Determine the value of p. Oh my word, this is amazing, because now, in other words, where there is n, we substitute with p. So it's like a point of intersection of both tn and this tn as well. So what do? We had initially tn equal to -n squared plus 11n plus 24. So it will be equal to, now tp will be -p squared plus 11p plus 24. Then the other one is tn is equal to -20 2n plus 20. So this TP will be equal to negative 2p plus 20. Just like, it's plus 10, sorry guys. Not seeing well, I thought it's 20, so it's plus 10. So we can see that TP is equal to TP. So now we can equate the two equation. Negative p squared plus 11p plus 24 is equal to negative 2p plus 10. Then after that, let's just play around with like terms and stuff like that. So let's transpose our left-hand side to the right-hand side. So 0 is equal to p squared minus 2p minus 11p plus 10 minus 24. 0 is equal to p squared minus 13p minus 14. Then after that, definitely we know how to solve this. We can just find factors p and p 14. So definitely we're going to have plus 1 minus 14. Then p plus 1 equal to 0. Or p minus 14 is equal to 0. Then again, p will be equal to negative 1, or p is equal to positive 14. But definitely, we can't have our value of p to be negative. So now we can conclude that, therefore, p is equal to 14. Just like that, 10 marks in the pocket. We are out. We are out. 10 marks, 10 minutes. 10 marks, 10 minutes. 10 marks, 10 minutes. 10 marks, 10 minutes. So always know that time is important. Time is the precious commodity which one cannot lose when writing the exam or the test. So please make sure that you do things fast. So practice more so that it can be inside of you. And dance whilst doing maths. 1 mark, 1 minute, 4 marks, 4 minutes, so that you can be able to finish the paper. 150 minutes. Great. I'm just joking. So guys, I'm just trying to encourage you that you can be able to speed up and write everything in time. Let's go to question number 2. Question number 2. What do we have there? Given the arithmetic series 3 plus 10 plus 17 plus. So we are given 3 plus 10 plus 17 plus. Then we are also given the last term. Let's go. Write down the fourth term in the series. This is great. In order for us to write down anything, we should break down the statement they give us, given the arithmetic series. So from the word go now, we know that we are dealing with an arithmetic series. So what do we know about an arithmetic series? We know that it has a first constant difference. Let's see that it has a first constant difference. So 10 minus 3 is equal to 7. 17 minus 10 is equal to 7, which means also the next term is going to be plus 7. So 17 plus 7, with your Casio calculator, don't do mental work, you do mistakes. So just get used to use your things, get used to use your calculator. 17 plus 7 is equal to 24. So on 2.1, let's go. On 2.1, T4, or the fourth term will be equal to 24. Just like that, we are cruising. Determine the general term of the series. Wow, they must take us serious, because we know that the general term of an arithmetic series is Tn equal to a plus n minus 1 times d. What is a? A is the first term in the sequence. So it's going to be equal to, what is our a? Our a is equal to 3 plus n minus, what is our d? Our d, we calculated it here, it's equal to 7. So d is equal to 7. Then now it's going to be equal to 3 plus 7 n minus 7 equal to 3. Let's just say it's 7n minus 4. So this is our Tn. Just like that, guys. Just like that. You don't even have to think too much. Your answer is already on the plane. So that's the idea behind everything, guys. That whatever we write it fast as possible and apply the principles which you have been taught from back then, from all the classes which we have been having. Now, let's look at the last question. Guys, I'm not seeing question. Are we all still okay? I'm looking also on the WhatsApp group. No one is saying anything. Are we guys still working together? Just put thumbs up on the description of the video so that we know that we are still cruising together. Life is nice when you understand maths. Okay. Whew. Can you do the last one? 2.3, which is sigma notation. Sigma. In physics, there's this thing for on momentum. Sigma before is equal to sigma after. Now we want to deal with sigma in this point. So let's deal with sigma. What do we have? What do we know about sigma? Sigma, sigma, sigma. So in order for us to do the sigma one is quite easy, guys. It's just us like, playing around with sigma and. So in order for us to do sigma, we must be able to know our general term, and we must know which is the first term of the sequence and which one is the last term of the sequence. So just like that, if you know those few things, then you'll be happy. You will live happy for the entire life, for your entire whole life. You'll be able to live happy. So without wasting much time, so this is going to be sigma, then our Tn is 7n minus 4. That's the first thing. First thing which you write is that, which is important. Just fix this. There we go. So that's the first thing which you should supposed to do. Then after that, it's n equal to 3, and the last term it's 150. Then after that, we are done. We get our marks. We are out. We are out. We are cruising. Ne? We are out. You are done. Get out of that question. Now let's go to question 3. Yebo Tutor making control test look so weak. What topic is this? This topic is number patterns. Okay, series and sequences for grade 12 work, Danny. Question number, sorry about that, question number 3 now. We don't have time. Time is not on our side. Let's go to question number 3. Where are you, question number 3? Here you are. Consider the progression 3:1. Seems like it's going to give us headache. 3:1 over 2:3:4 over 10 is to, then write down the next two. Do we see something about this? The 3 is constant. 3 is constant, which means the next two terms, let's just start by writing it so that it can be proper. So we are given 3:1 over 2 is to 3 is to 4 over 10 is to 3 is to 16 over 50. Then need the next two terms. So guys, let's just look at this in this way. We see that it's 3, 3, 3, which means this is an arithmetic. It's just constant. So the moment we see that this one is constant, it shouldn't be giving us problems. Automatically, it can't. We can't allow it to give us problem. We can't give it power over us. So definitely this next term is going to be 3. Then let's see what's happening in this sequence. So these are called mixed sequences. So now let's check what's happening on this other side of the sequence. Let's check it out. Let's check it out. What's happening on the other sequence? So we have 4 over 10, 1 over 2. If we say T2 divided by T1, so that we see if it's an arithmetic progression or it's what. So T2 divided by T1 is going to be 4 over 10 divided by 1 over 2, which is 4 over 10 times 2 over 1. Then that will be 8 over 10, which is equal to 4 over 5. This is not even necessary. Let me remove it so that we don't waste time. So we just use our calculator, then we get 4 over 5. Let's see if we say 16 over 50 divided by 4 over 10 now. So this will be 16 over 50 times 10 over 4. This will be, okay, then that will be 4 over 5. So we can see that it has the same constant ratio. So in other words, the R here is equal to 4 over 5. So for that instant, automatically we know that the other one is a geometric, other one is the arithmetic. So the geometric one is going to be 16 over 50 multiplied by 4 over 5. So it's going to be 16 times 4, it's 64. 5 times 50, it's 250. So to answer the question, let's go back to the question which they wanted on 3.1.1. So the next term is going to be 3 is to 64 over 250. So how did we see that? We were able to realize that this is a mixed number pattern. We can see that there's a constant, and we prove that also this one, which is having fractions, is an arithmetic progression. It's a geometric progression. So that makes our workload so easy for us, guys. So let's go, let's proceed. Let's go now. Calculate the sum of the first 35 terms of the progression. How are we going to calculate the sum of the first this is easy, guys, because we know that 35, first 35. So 3.1.2, which means it's gonna be 3 times 18. Okay, so 35 divided by 2 gonna give us 17.5. So it means other one must be 18, other one must be 17. So this one, it's already 13 times 3 times 8. So we can actually see that we're gonna get equal to 54. Okay, then after that, other one is gonna be the sum of the same 17 terms. Other one is 18. Since it's constant, then the other one, which is fraction, we'll use 17. So the sum of the first 17 terms in the geometric, we know it's always um, um, a, which is 1 over 2, then r 4 over 5 to the power 17 minus 1 divided by 4 over 5 minus 1. Then using our Casio calculator, then I'm using it now, I'm getting 2.44. Then therefore the sum of the 35 terms will be the sum of the 18 plus the sum of 17 terms. The 18 one, we calculated just 3 times 8, then we get 54 plus 2.44. That one will be 56.44. Then you're done. So let me just recap on this one. I think it was a bit confusing. So guys, what is important is to understand this is a mixed sequence. So a mixed sequence is always in this order. So please make sure that you see that the constant one is the arithmetic one, then the other one is a geometric progression. So the moment we're able to realize that part by proving, actually, so we're able to see that this is the geometric by using t2 over t1. So it's 4 over 10 divided by 1 over 2, then we go to 4 over 5, then another one again, this one, and we saw that the constant ratio is the same. So that made our lives easier. Then the next thing, the same, calculate the sum of the first 35 terms. So since this is not an even number, so we give 18 for the constant one, then 17, which is odd, we give it to the one which is a geometric progression. How do we calculate the sum of terms in the geometric? So someone will say, why are we seeing the formula only? We calculate the sum of a geometric by say it's a r to the power n minus 1 over r minus 1, where r is the constant ratio. Then after that, we can solve this. Then 3.2, the easiest one. Calculate from n to infinity 5n y minus 1. So that one is easy. We know that if it's given as n is equal to 3 to infinity, then we're given 5 times 3, 1 minus n. So let's start by calculating the terms in this sequence, because this is a general term. So t1 will be equal to 5 times 3, 1 minus 1. So 1 minus 1 is equal to 0. 3 to the power 0 is equal to 1. So the first term is 5. If I'm not mistaken, let me see. Oh, it's not starting on 1, it's starting on 3. Sorry guys, sorry guys, because you can see here it's starting from 3. I was not seeing well. So t1 will be 1 minus 3. So this will be 5 times 3 to the power negative 2, which would be equal to 5 over 9. Then t2 will be equal to what? Now t2 will be equal to 5 over 27. Because now it's going to be 1 minus 4, because you are going upwards. 1 minus 4, then it's going to be 3 to the power of negative 3, and 3 to the power negative 3 is 1 over 27. Then let's now look for our value of r. Then our r will be equal to t2 divided by t1. What is t2? It's 5 over 27 divided by 5 over 9. Then we use our Casio calculator again. Cross, then we are left with r equal to 1 over 3. Then now the sum to infinity is equal to a over 1 minus r. What is a? It's 5 over 9 minus 1 minus 1 over 3. Then now we can use our calculator now, guys. Then using my cashier, I'm getting 5 over 6. So this is the sum to infinity. This equation is important. Then after that, we are living a happy life. Living happy ever after. Are we going to do trig or Euclidean geometry? Yes, we're going to do trig and Euclidean geometry next week. Now we are preparing for the controlled test for term 1. So since we are preparing for the controlled test for term 1, we want to make sure that all the topics to be covered in test 1, we are all happy and all of them, they are all sorted for us. So please bear with us. We want to make sure that all students pass, then because others will be using the results for even writing or for applying for university. Let's proceed then. Then we have the functions. This one we won't do it today, question 4, because it's basically usually having grade 11 and grade 12, of which in grade 12 we usually only taught this part. I put at this part so that you can just use it for extra help. We can see there's a parabola here. We can see there's a hyperbola. We can see that we also have a straight line function there. So it's a combination of all functions, of which in the control test they'll only give you the one where you're supposed to determine the inverse of the function. So we're going to rush to question 5 and question number 6 so that we can be able to answer those few questions. All right. So we're going to rush to those few questions so that we can be able to answer those few questions which they have given us. So let's look at question number 5 now. So question 4, it's not really on the scope of our control test. Question number 5. Now we are on question number 5, guys. Guys, I'm not seeing question. Ask me questions. I'm here to answer your questions so that we can have a happy life together and we can pass together. The graph h of x is equal to ax, where a is greater than 0. We can definitely see that the a value is greater than 0. We can all see that because we can see the graph is above the x-axis. And it is sketched below with p, which is -1 is to 1 over 2. That's the point, is on h. Great, definitely they will ask us calculate the equation of h of x, and they'll ask us those boring questions which we already know. So without wasting much time, let's answer them. Let's tell them, let's show them that we know what we are doing. Write down the coordinates of q. Wow, q, it's easy. It's easy, guys, because we can see that q is the y-intercept. So for instance, we have h of x equal to a to the x. Okay, so if we say y is equal to a to the x, and we can see that q is y, it's 0 is to y. 0 is to y because it's on the y-intercept, so it's going to be y equal to a to the power 0, which is equal to 1. So therefore the value of q will be 0 is to 1. So this is the coordinates of q. Just like this one was easy. You don't even have to think about it. You just have to substitute so that you can get the correct answers. So the basic or the most important things on the functions is to be able to analyze your graph before you answer the question. So just like how I analyzed here, it's how you also supposed to analyze the question before you answer any problem. Determine the value of a. How can we do that? That one is straightforward. So we are given y is equal to a to the power x. So we just have to substitute point p, the point which they have given us, which is -1 is to 1 over 2. So where we see y, we put 1 over 2 equal to a to the power -1. So 1 over 2 can be equal to a to the power -1. Okay, this is the same as 1 over 2 is the same as 1 over a because of the rules of exponents. So a is equal to 2. Okay, so then therefore our a value is equal to 2, just like that. This one is also easy, but we're just supposed to substitute the coordinates which we are given. So we substituted the coordinates of p, then we had the value of a to be equal to 1 or to be equal to 2. Write down the equation of h. the inverse function. 5.3. This is easy, guys. Why? Because we know that y is equal to 2 to the power x. So the first thing we do when we are determining the inverse, we swap x and y. So it's going to be x is equal to 2 to the power y. Then now we solve for y. So it's going to be log of 2 times x equal to y. Yo, for 2 marks, guys. Come on. Then therefore, h inverse of x is equal to log 2 of x. Then after that, we are happy. We are happy. We are cruising. No need for us to fail. 5.4, sketch the graph of h inverse in your answer book. Clearly show all the intercept with the x's. This is easy, guys. So the initial graph was this one. Let's draw it. Mine is ugly. Please make sure that yours is good. So we have a point here, which was -1 is to 1 over 2. Then we have a point Q here, which was 0 is to 1. Now we must draw or plot the inverse. I want to tell you something. This is my writing is not writing. Here we go. This is the reflection line. So in order for us to plot this, so this is 0 is to 1. So we swap the point to be 1 to 0. So 1 is to 0 somewhere here. Then this one again we swap. So it's going to be 0, 0,5 is to 1. So it's somewhere here. So our inverse function will be like this. So this is h inverse. And this point here is 1 is to 0 because it's the reflection of point Q. Then this point here is the reflection of point P here. So just say P prime and say this is Q prime. So on P prime, let's write, no, this is not P prime, this is just P. Then this is P prime now, which is 1 over 2 is to -1. So in other words, when you are plotting the inverse of a function, you are just swapping the coordinates of the original function so that it can suitify the function which you are dealing with now at this point. Okay, so please always know that point. It's so important and so crucial. Let's continue. Hence, hence, which means use what you have already have from above. No, sorry, we are on 5.4, 5.5 first. 5.5, write down the domain of h inverse. That's easy. How can we determine the domain? The domain is the x values, okay? So we can see that our graph must be x greater than 0. So this is the domain because we can see that the graph should not touch this part. So all the x values are greater than 0. So that will be our domain. So the domain of the h inverse is the range of the original function. So they just swap. Then 5.6, hence or otherwise, determine the values of x for which log 2x is greater than 1. That's easy, guys, because it's x must be greater than 2. Usually, when I was in grade 12, I used to solve this because I couldn't see it. So log 2x it's greater than 1, so x will be greater than 2 to the power 1. So x is greater than 2, just like that. So that's how I used to solve it, or that's how I used to get the answer. Or you can be able to see on the graph, log 2 is x, which means where on the function is the inverse function of x greater than 1. So we can see that it's greater than 1 when x is equal to 2. So those kind of stuff, that's the analysis of the graph. Then 5.7. If g of x is equal to 100 times 3 to the power x, calculate the value of x, which h of x is equal to, this is direct. H of x is equal to g of x. So in other words, we are calculating the point of intersection. What is h of x? Is 2 to the x equal to 100 times 3 to the power x. Then after this, what do we do next? Because now we are working with what we don't really love. So we can say 2x divided by 3x is equal to 100, okay? Then after that, we can see that this can be 2 over 3 the power of x equal to 100. So x according to the log can be equal to log 2 over 3 multiplied by 100, because we are just reducing everything and applying the log. Then using our Casio calculator now, it's log of 2 over 3 multiplied by 100. Then we get our answer to be negative 11.36. We are just cruising, guys. We are just cruising. So it's so important, it's so crucial for us to understand these few basic stuff. Okay, it's very, very important. Please, please, please always know that this is important. Then let's do question 6, the last question for the day. Question 6. The graph of f of x is equal to negative root 27 of x, where x is greater or equal to 0. And is sketched below. The point P is 3 is to negative 9 lies on the graph of f. Here is our graph. Use the graph to determine for which values of x will f of x be greater or equal to negative 9. Values of x, definitely we can see that is between 6.1, 0 less than x less than 3, because they want the values of x. So we can see that this graph is greater or equal to negative 9 on the y-axis between 0 and positive 3. That's where we can see, because we are looking also on the point of P. So that's how we get that point. Then 6.2, write down the equation of f inverse in the form of y. Indicate all restrictions. Wow. So initially we are given y is equal to negative root 27x. So again, as always, we swap x and y. So it's going to be negative 27 y. Then now we solve for x. So we divide by negative 1 as always. Then after that we have our answer. So it just depends on how we want to solve the problem as well. So this is going to be negative x equal to root 27 y. We square both sides. Okay, then remove the root, then it's going to be x squared equal to 27y. We divide by 27, divide by 27, and therefore y is equal to x squared over 27. For x must be less or equal to 0. Then we can actually see that. Then therefore our f inverse of x will be equal to x squared over 27. So basically, always when we are doing the inverse, guys, the steps are the same. We swap x and y, then after that we solve for y. Then now we are sketching the graph. How can we sketch the graph, guys? This should also be easy. This should also be easy, just like last time. Here is a function, and this function is found here with the point somewhere here, which is point P, which is 3 is to negative 9. So we're just reflecting this on the line of action. So this one now, also the inverse will now be like this. And you have the point here, which is negative 9 is to 3. So we are just reflecting this point along the line of action, along the line y equal to x, so that we can have the mirror of this point. So the mirror of this point will be negative 9 is to 3. So we are just swapping here. So this is like p prime. Original p is 3 is to negative 9. Then the other one, p prime, will be 3 negative 9, sorry, is to 3. So we're just swapping the two. Then after that we are happy. Let's do the last question of the day, guys, and we are done. Describe the transformation from f to g if g of x is equal to 27 of x. This is easy, guys. The transformation. So we can actually see that initially we're given f of x to be equal to negative 27x, like this. Now they're saying that the graph f has been transformed to g, and now our g of x is equal to positive 27x, like this, which means it has been reflected along the x-axis. So it has been reflected along the x-axis. Then you get your 1 mark. So totally, we get our 50 marks. We only didn't do question 1, so question 4 only, but we did all other problems. We did all other problems. So this is reflected along the x-axis, guys. It's reflected along the x-axis. So here we are. Here's everything. So today we did a fast session, 51 long. That was quite long. But the idea behind our tutorial session today is that I wanted us to look at the preparation for our final test. Without wasting more time, guys, please do follow us on Instagram, do follow us on TikTok and Facebook. We are here to assist. If you want more depth understanding, just join the WhatsApp group in the description of this video. Then also in the group, you can see there's an admin code Yebo Tutor. Just text that number if you have any question, anytime, anywhere. Real time, we assist students. Till we meet again, have a blessed evening.